Starting with the decimation of computer-signal processing, in short, we can call it MRSP. So, multi-root signal processing is basically an efficient technique for changing the sampling frequency of a signal digital. The fundamental operations in multi-root signal processing are decimation and integration. So they allow the sampling frequency to be increased or decreased without the undesirable effects of errors such as digestion and aliasing. Right now, the main advantages of multi-root signal processing. First one is reduce cost. Second one is it is going to reduce the complexity. Third one is basically the reduction in storage, or you could say the transmission rate. And finally, low noise. Now, first of all, what is the main concept of multi-root signal processing? Here's one mark. which is the main concept and very important concept, that is multi-rate signal processing. इससे पहले हमने सैम्पलिंग प्रोसेस पढ़ा था, and in the sampling process, let me first erase it. Okay. In sampling, what we did that we started with an analog signal, right? And after sampling, the whole process that is involved in it, what we got an equivalent discrete signal that was being sampled at a particular frequency and a time period, that is t and s, right? Mostly आपके signals with digital domains में exist कर रहे थे, they are being operating at a particular sampling frequency. वो tune हुए होते हैं sampling frequency. In certain cases, we have to make the signal compatible with different systems. सिग्नल की अपनी फ्रीक्वेंसी डिफरेंट होती है, सिस्टम जिस फ्रीक्वेंसी पे ऑपरेट कर रहा होता है वो डिफरेंट होता है. सो इन दैट केस वी हैव टू मेक दोज फ्रीक्वेंसीज कंपैटिबल विद ईच अदर सो दैट वन सिग्नल कैन बी ऑपरेटेड ऑन अनदर सिग्नल. ठीक, और उस कंपैटिबिलिटी के मिसमैच को ओवरकम करने के लिए दो भी सिनेरियोज हो सकते हैं. या तो हमें अपनी फ्रीक्वेंसी को इंक्रीज करना होगा या हमें अपनी फ्रीक्वेंसी को डिक्रीज करना होगा. If we have to increase our sampling frequency, then we are going for the process of interpolation. If we are going to decrease our sampling frequency by a certain factor, then that process is known as decimation. Right? A very common example of this is called, for example, digital audio tape. वो ऑपरेट करती है 48 किलोहर्ट्ज पे, राइट? At the other end, we have a CD player which operates on, say, 44.1 kilohertz. In order to record the data from a digital audio tape to a CD player, you have to reduce your frequency, that is a 48 kilohertz, to 44.1 kilohertz, right? This is known as changing of frequency, either reducing it by a certain factor or increasing it by a certain factor. So that reduction or increasing your sampling frequency, that is changing your sampling frequency, this process is known as multi-rate signal processing, जिसमें दो ही possibilities हैं, या तो आप increase कर रहे हैं या अपनी frequency को decrease कर रहे हैं. So if you are decreasing your sampling frequency by a certain factor, then that process will be known as decimation. If you are going to increase your sampling frequency by a certain factor, then that process is known as interpolation. Right? Now, today we are going to start with the topic that is decimation. Okay. Let me first write its definition. What is basically a decimation? Another name for decimation is downsampling. And another name, compressor. These three words are one and the same thing that denote the process of decimation. Right? Okay, let me first write its definition. Decimation is the process of reducing the sampling rate by an इंटीजर फैक्टर और इस फैक्टर को हम डिनोट करते हैं कैपिटल एन से। जैसे हमने उसको 2 टाइम्स डिक्रीज करना है, हमने इसे 3 टाइम्स डिक्रीज करना है और सो ठीक, वो हमने कितने टाइम्स डिक्रीज करना है उस फैक्टर को हम कहते हैं डेसिमेटिंग फैक्टर, and that is conventionally denoted by capital N. We're not going to use any other letter for it. It is also called compressor. Right? Now the basic purpose of conversion to a new data bit is to make the processing easier, because जब तक वो उसके accordingly ट्यून नहीं होगा उस फ्रीक्वेंसी पे, you are not able to go for the processing. You are not going to enter that system that is going to process that data. And most of all, to achieve compatibility with another system. For example, if we reduce the weight from, say, 10 kilohertz, sorry, from 100 kilohertz to 10 kilohertz. ठीक है ना? For example, एक system था that was operating at 100 kilohertz and हमारे पास जो सिग्नल है वो बेसिकली ज़्यादा था, तो उसको उसके अकॉर्डिंगली रिड्यूस करना है. Then at a stroke we reduce the computational burden by a factor of 10. ये आपके सिस्टम की जितनी सैंपल फ्रिक्वेंसी हाई होती है, उतनी ज़्यादा सैंपल्स आपको उनके साथ डील करना पड़ता है, डेफिनेटली वो आपके सिस्टम के ऊपर बर्डन भी है, इट इज गोइंग टू increase your computational cost. Secondly, it is also going to increase the number of computations. So once we are going for downsampling, definitely there are some errors in it, but at the other end we are having a benefit, that is we are going to have a reduced computational burden, which is going to result in a reduced cost. Okay, let me draw the leading ends. Please rejoin the block diagram of the decimation process. We are going to start with cutoff thing. अब यहाँ पे most important point जो मैंने definition में भी लिखा था, we are going to change the sampling rate or the sampling frequency digitally. It means we are totally going to operate in the discrete domain. ठीक है, सिग्नल आपके पास सैंपल हो चुका, तो discrete form में conversion हो चुकी. Now you are going to change its sampling frequency in a certain manner once the signal is in the discrete domain. First, we are going to pass this signal through a system that is basically a anti-aliasing filter, which is having some frequency response, impulse response, that is h of k. ठीक है? और इसको मैं फ्रीक्वेंसी डोमेन में लिख देती हूँ h d कह देते हैं ऑफ e पावर j। डी यहाँ पे डिनोट करेंगे डेसिमेशन प्रोसेस का जो है उसका फ्रीक्वेंसी रिस्पॉन्स फिल्टर का। Then comes we are going to have y of n, which is equals to x of n. This is written this whole process that is basically a discrete.